Let's do checkpoint 6.11. In this checkpoint, they want us to show that the vector field f, which is equal to y in the I component, minus x squared y in the j component, is not conservative. To check if a vector field is conservative, well, let's rephrase that. To check if a two-dimensional vector field is conservative, what we want to do is we want to consider this function, or this vector field, as having a function of xy in the x component, and then another function q of xy in the y component. And if this was a vector field, then this would have come from a gradient of some function, which is the partial with respect to x and the partial with respect to y. And then if you remember, when we were first studying functions of several variables, we saw that for nice functions that we deal with, that the second order mixed partial derivatives were equal. Well, if p is actually fx, then the partial derivative of p with respect to, and this is where we're going to make our connection, the partial derivative of p with respect to y should equal to the partial derivative of q with respect to x. And so if we take each of these derivatives with respect to the other variable, we should get them to equal each other if they are in fact conservative. So let's do that. P is equal to y, so the partial derivative of p with respect to y is going to be the derivative of y with respect to y, which is just 1. Q is equal to negative x squared y, so the partial derivative of q with respect to x is equal to negative 2xy. And clearly these two are not equal, and then we can conclude, therefore, f is not conservative. Okay, I hope that helps.